Hello, my name is David Finkelstein, and I'm a senior bioinformatics research scientist here at St. Jude Cloud. And today I'm going to show you how to make a mutation heat map. First, navigate to proteinpaint.stjude.org. That is the page that we're looking at now. Underneath the Launch Apps heading, we have a mutation heat map icon. If you navigate down to it, click it, you're taken to a parameters page. In the upper left-hand corner of the page, we have a documentation button with further detail as needed. Underneath this, we have our list of parameters. And the first parameter to consider is genome. The app supports human genome, mouse genome, zebrafish, fly, chicken, and rat. We also have reference data. That'll become important later. The app supports a series of different kinds of mutations: SNVs and indels, structural variants, fusion genes, internal tandem repeats, deletions, truncations, and copy number variants. Importantly, each one of these mutation types has its own file format. The examples are available here on the parameter page, and it is certainly worth taking the time to make sure that your own data conforms to the format so that the app can take it in more easily. Next, let me show you what an example looks like here. Let's click on the example, and we're taken to this ERG map. At the top, we have our legend. Mutations are classed and color-coded. We also have metadata available. The top of the heat map is labeled by sample identifier. The left-hand rows are labeled by genes, and they're classed and on the right-hand side and labeled. Importantly, if your data is a Hugo format, we're able to access the underlying reference data that I mentioned earlier, and we can see this ProteinPaint visualization of your mutations. Notice that they're still color-coded by class, they're scaled by frequency, and they're localized along the amino acid model. Importantly, the reference data gives us protein motifs so that we can better understand the significance of each one of these mutations. Let me show you how you get your data into a heat map. First, we come up here to the tab, Data. Click on that, and we see Downloads, which will become important later, and tab-separated inputs. First, we go to Gene Groups. Click on that, and what we see are two-column headerless tab-delimited text file with gene descriptors on the left-hand side and gene identifiers on the right. Importantly, we have great flexibility about what we can use here. It's also important to note that the order in which you place these genes is the order in which it appears on the heat map. We are able to select this file, cut it, paste our own file in, and update as needed. As long as the gene identifiers do exist within your underlying mutation file, the heat map will populate. If we click on data one more time, go over to sample groups, we see a very similar format. Again, tab-delimited text file, headerless, two-column format with the descriptor on the left-hand side, and in this case, the sample identifier on the right. Once again, the sample identifier must conform to that within your own mutation file so that the app can find the appropriate mutations. Again, this can be highlighted, cut, a new file pasted in, and updated as needed. Last, I'm going to show you the metadata file. This is a little bit more complex. Again, it's tab-delimited text file, but this time we do have a header. On the left-hand side, we have sample identifier. We have a term, which is what appears in the legend, and then we have group and value, followed by color and legend order. The first instance of a new value has a color. In this case, we have a term, white. We can also use simple terms like red, blue, green, or we can use hex code as shown here in this example. The app will also take RGB values. Let me show you an example of a continuous variable, which can also be rendered in a heatmap mutation file. For the next step, it's necessary to navigate to viz.stjude.cloud. That's viz.stjude.cloud. That's the page we're looking at now. For convenience, I've already signed in, but let me show you our public visualization list. If you click on this list, you'll see cards for all of our public visualizations. If we type in a keyword like kids for our Genome for Kids mutational heat maps, you'll see our 2 visualizations from that paper, the one that conforms to the paper itself, and our demonstration example, which we use for this video teaching purposes. We click on the demo. Our visualization comes up. We can see that we have our continuous meta variable that we were talking about earlier. Here, let me show you what that looks like in the data file. If we go to metadata long, roll down to age, we see that that's numeric, not categorical. It's headed with a color at the first instance, and then 2 tabs over is color scale in camel case, which is under the render as column. And that gives us a continuous legend from less than 1 to greater than 21 in this case. It's important to preserve your visualization by saving a JSON file. And you can do that simply by going to Data and going to Downloads and pressing the JSON file, and it will download locally to your desktop or laptop. Another way is once you have a visualization shown, in this particular instance, we're able to actually see the JSON file. In this case, we can highlight it and copy it. If you bear with me for a moment, I'm going to do that now. At the very end of the JSON file, we see metabar names, and we need to take this last bracket. If we copy that, we can preserve it and use it again. Again, I've signed in, so I can go to my dashboard, click on Create Visualization, and this takes me to the Visualization Editor page, which, like the ProteinPaint page, has an apps column with a mutation landscape heat map. Click on the icon, and we're taken to another visualization, which is default loaded with data. And here we see show heat map. We have no JSON file, but we can add it. First, we need to put a comma after this show heat map. Then we enter and we paste. And now our visualization includes that JSON that we showed before. We navigate to the top, show you one last detail that's important. You can see here that this is highlighted in a different color. That's because it's necessary in these heat maps to have quotes around the term heat map JSON. If we save and reload, the image should update. If there is an error in the typing, we'll get an error code. Here we go. Let me drop the code editor. If you need further information, please contact us at support@stjude.cloud, or go through our help guides, which include specific code examples for each one of our visualizations. Thank you for your attention.